Assalamualaikum. Today I will presenting on the topic of modification of glass transition, temperature through carbohydrate additions, effect upon color and anthocyanin pigment stability in frozen strawberry juices, a study conducted by Torrigiani et al. In 1999. The fruit I selected is the strawberry, specifically the Honeo cultivar. Strawberries are not only popular for their taste and bright red color, but they are also natural, rich in soluble carbohydrates such as glucose, fructose, and sucrose. These sugars make strawberries a potential source of carbohydrate ingredients in food processing. In addition, strawberries contain anthocyanin pigments, mainly pelargonidine 3-glucoside and cyanidin 3-glucoside, which give them their characteristic red color. However, these pigments are chemically unstable and can degrade during processing and storage. This study investigates how adding carbohydrates like maltose, sorbitol, and glucose, fructose or sucrose mixture can influence pigment stability and thermal behavior in frozen strawberry juice. The first step in the study was sample preparation. Strawberries were ground and juice was obtained by centrifugation. To this juice, different carbohydrates were added at concentration of 20% week by week. The carbohydrates tested were maltose, sorbitol, and a mixture of glucose, fructose, and sucrose in the same ratio as found naturally in strawberries. A control sample of raw juice without added carbohydrates was also prepared. The juices were then frozen and stored at -10 degrees Celsius. Now, in terms of extraction, the soluble carbohydrates were naturally present in the juice and could be considered part of the water extraction fraction. However, unlike some carbohydrates, this research did not include ethanol precipitation to isolate soluble fiber or oligosaccharides. That is a limitation of the study, but the expected compounds were mainly simple sugar like glucose, fructose, sucrose, maltose, and sorbitol. This process ensured that the researcher could directly compare how different carbohydrate additions influence stability during frozen storage. Next, the researcher used high-performance liquid chromatography or HPLC to analyze the sugar composition of the juices. HPLC works by separating compounds based on their polarity and interaction with the stationary phase. In this case, it allows precise quantification of sugars present in the juice samples. The results show that sucrose decreased during storage while glucose and fructose increased. This was due to hydrolysis of sucrose into its monosaccharide components. Interestingly, maltose and sorbitol remain stable throughout storage. This finding is important because it shows that the sugar profile of strawberry juice changed during frozen storage and that added carbohydrate can help stabilize the system. If you look at the table 3 in the article, you can see the clear trend, which is sucrose levels drop over time while glucose and fructose rise. This demonstrates the usefulness of HPLC in monitoring sugar transformations in food system. The next technique used was differential scanning calorimetry or DSC. DSC measures the heat flow associated with thermal transition in a sample, and in this study, it was used to determine the glass transition temperature or TG of the unfrozen fraction of the juice. The thermogram revealed that maltose addition raised TG, making the system more stable. Sorbitol, on the other hand, lowered TG, but surprisingly, sorbitol-enriched juice showed the highest pigment retention. This is a fascinating result because it shows that TG alone cannot fully explain pigment stability. While maltose increased TG, sorbitol provide better protection for anthocyanins despite lowering TG. So the relevance of DSC analysis is clear, which is understanding TG help food scientists design formulation that preserve color and quality during frozen storage. However, this study also highlights that other factors such as the chemical nature of the carbohydrate play a role in protecting pigments. Now, let's discuss the broader findings. First, the study demonstrates the potential of strawberry juice as a source of soluble carbohydrates. The natural sugar combined with added carbohydrates influence both thermal behavior and pigment stability. Second, the strengths of the study include its multi-technique approach. The researcher used DSC, DMTA, conductivity measurements, HPLC, and color analysis. This comprehensive methodology allowed them to examine both physical and chemical changes during frozen storage. There are also limitations for this article. The study did not include ethanol precipitation or analysis of soluble fiber fraction, so it focused mainly on simple sugar. This means the potential of strawberry as a source of oligosaccharide or soluble fiber was not explored. The importance of the analytical technique cannot be overstated. HPLC provides detailed sugar profiling showing sucrose hydrolysis and stability of added sugar. DSC reveals how TG shifts with different carbohydrate addition, linking thermal behavior to storage stability. Together, these methods give valuable insight into how frozen food formulation can be improved. To conclude, the study found that carbohydrate additions modify both the glass transition temperature and pigment stability in frozen strawberry juice. Sorbitol was the most effective in retaining anthocyanins and maintain color, even though it lowered TG. Maltose raised TG but was less protective over long storage. The glucose-fructose-sucrose mixture provided moderate protections. Importantly, the study showed that there is no simple correlations between TG and pigment loss. Instead, the protective role depends on the chemical nature of the carbohydrate. So overall, strawberry juice demonstrates potential as a soluble carbohydrate source for food preservation. By understanding how different carbohydrates influence stability, food scientists can design better formulation to maintain quality during frozen storage. Thank you for listening. So this study highlights how combining analytical techniques like HPLC and DSC with careful formulation can improve the stability of frozen fruit products. Strawberries with their natural sugar and pigments are an excellent model for exploring this effect. I hope this presentation has given you a clear understanding of the role of carbohydrates in modifying glass transition temperature and protecting anthocyanin in frozen strawberry juice.